first of all for having me here at this this interesting webinar. So I'll try to talk a little bit of a provocative title, I guess, but I'm sure we will all agree at the end of this presentation. I'll try to explain why the carbon neutral energy transition will actually imply the use of lots of carbon. I won't bother you too long with NG and NG research, but just one slide on it. Then I'll talk about three pathways to reach this carbon neutrality, the way we think at NG that this carbon neutrality is achievable, and then to end up with a conclusion. So NG, as you know, is a large utility company, yeah? And it's really taking this low carbon or carbon neutrality serious. And so our purpose, I will let you read the strategic sentences, but we are a large electricity and gas or natural gas in the past, but more and more, of course, bio and synthetic gas player. So we're both an electricity and a large gas company active worldwide. With an NG, I'm in the scientific department of NG Research, where we have about 900 researchers working on a variety of topics. This is just to give you an overview of what we're working on. And of course, hydrogen is an important one, but also we like to see CO2 as a resource rather than as an issue. So we have a CO2 as a resource lab. We also have a water and chemistry lab and life cycle assessment lab. So we work on a variety, of course, wind and PV. At NG, we're not really, no, not always at least. We sometimes are technology developers, but in many of the cases, we like to pilot things. We like to investigate, collaborate on existing immature technologies, and then try to test them in real life, and so that we can inform our business units on the potential and the challenges left with these new technologies. In some cases, we do develop our technology alone, like, for example, in the biomass gasification Gaia project, which is a gasification of dry biomass versus biomethane. There we also act as a technology developer. But of course, we are not like a Siemens or a GE, where we're pure technology developers. We're more piloting in collaboration with existing partners. So these three pathways towards our the first one, and I will not spend a lot of time on it. Everybody knows this. It's increase our energy efficiency. We should not forget that, and of course increase our circularity, where waste becomes a feedstock. Just one example where we work on quite a lot with an NG is this biomass, biogas. I'm sorry, which is a perfect example of a circular thinking, where you collect your waste and you feed it to bacteria who produce you biogas, and you can even have the digested spread on the fields again, and then you can have your biomethane upgraded and injected in your gas grid, where you can collect the waste from. So this certainly will be part of the solution to increase efficiency and circularity. And then, of course, the second one where a lot of people are talking about, and people are even opposing it, should we electrify or should we gasify? I think by the end of the talk, I'm hoping to have convinced you that we should do both, of course, and we should electrify as much as possible and far beyond electric cars, and just making our electricity green. This comes from the International Energy Agency Energy Technology Perspectives, which was just published in September, where they showed, so to get carbon neutral by this 2070, where we have net zero emissions, we need to get rid of this 36 gigaton of CO2. And making our electricity clean is crucial and important, and it will count up to, what is this, 38%, 40%, but it will not be enough. So we will need also to, and especially you will see, we will need a lot of effort also to not decarbonize, but make our industry carbon neutral. And that is a lot more difficult than see that a lot later than greenifying our electricity, which clearly has started today, and where it's a lot easier. We have PV, we have wind, we have hydro. We know how to make it a carbon neutral. In industry, it's a lot difficult, and of course, electrifying part of the industry will be crucial as well to get there. But will not be enough just with electricity, we will of course need molecules to do this as well. Part of the problem is it's also not just sufficient, and this comes from the same publication, to start building new clean facilities is crucial, but we also need to think about how we can make carbon neutral, make our industry, existing industry, carbon neutral. If you look at the lifetime of, for example, the steel making worldwide, well, about 90% have not even reached half of their age. So it's not sufficient to build new clean facilities. We really need to think also about how we can make the existing assets carbon neutral. And there, of course, carbon capture, utilization, and storage, and hydrogen will be required along with electricity, of course. But it's impossible to electrify everything. So I've said we need molecules, and just a few more slides on what these could be and what these should look like. Of course, the most obvious one is hydrogen, and hydrogen has a lot of potential, and it's an energy carrier, and you could make it from renewable electricity. It can even be a byproduct, which in some cases is today. We can do steam methane reforming, which is where our hydrogen comes from today, but you can combine it with CCS, which we then refer to as blue hydrogen. We can even make, I think this is called purple hydrogen, where you do pyrolysis, where you end up with fixed carbon and your hydrogen. So there's a lot of possibilities to make carbon to make hydrogen in a carbon neutral way, let's say. But the big challenge with hydrogen is that it's very, very hard to store and to transport this. And this probably is the most important, or the slide that I like most of this presentation. It has a really extreme low energy density, so it makes it very, very hard to store it and to move it around. If you want to transport, for example, 10 kilowatt-hour of energy, you can do that with 1 liter of diesel. If you go up to the hydrogen, if you compress it up to 350 bars, like is indicated here, well, we need about 13 times as much volume. If you compress it up to 700 bars, you still need to move around about 7 times as much volume. And remember, hydrogen is a very, very small molecule as well. So the containment that this hydrogen is in, it has to be really solid containers as well, because hydrogen likes to it's a very small molecule, so it escapes through lots of materials. Liquefied, then we're coming to closer. It's only 4 times the volumes, but liquefied, we need down to minus 250 degrees. And by doing that with the current technologies, but we're working on them to improve them, of course, but you lose between 35 and 40% of your energy contained within your hydrogen just to liquefy it. And even when you have got liquefied it, you still need to move around about 4 times as much. So I always say, if you can use your electricity immediately, well, please do so. That's great. We will not be able to do that everywhere, especially in industry. We will need to go to hydrogen. I think hydrogen is a great option if you can have it on site, produce it and consume it on site. But once you have to start moving and transporting it around, we probably need something better than hydrogen. Or we could use this hydrogen and turn it into synthetic hydrocarbons. And this is certainly what we also have to do, because we will need to continue moving energy around from areas where a lot of people live, or to areas where a lot of people live. This is the areas where a lot of people live. And these, unfortunately enough, do not coincide with the areas, for example, where you have access to the largest solar irradiance. So this is where a lot of people live. Unfortunately, it's not coinciding with the areas where we have lots of sunshine. So it's clear that we will need to continue moving renewable energy this time from areas where it's available at cheap and abundant to areas where most of the people live. And that, for sure, hydrogen will be crucial in doing that. We will probably not transport it as hydrogen, but turn it into a hydrocarbon. So making it react with CO2, so we can turn it into methane, for example, because if you had a look at methane here, methane is quite efficient. We only have to go down to minus 160 degrees. We really know how to do this, to make LNG, so liquefied natural gas. It's a mature process. All the infrastructure is in place to liquefy it, but also to transport it. So probably transporting it as methane or as ammonia or as methanol, where we have infrastructure for, we know how to do it, technologies are mature, probably makes a lot of sense to use these molecules instead of pure hydrogen to transport energy from these areas to the areas where people live. And this is just the last slide to give you two examples of where we are working on. This is so the hydrogen coming from your PEM electrodes. In this case, we make it react with CO2 coming from a biogas installation. So the ones that I presented before, and then turning it into synthetic methane, which you can then feed into your gas network, or you can store it, you can use it for mobility. Anyway, from this moment here, we have all the existing infrastructure downstream to transport it and to use it. The same here, this is a different process. This is actually a catalytic, a chemical reaction, making CO2 react with hydrogen over a catalyst, chemical catalyst. Here it's a biological process. With an NG, we're not very sure yet whether there be a winner of these two. We think probably they will coexist, and we will try to understand where it makes sense to use chemical processes and where it makes sense to use biological processes. So just an example to end up with. And then the conclusion, I think the conclusion is that initiatives like this, like SUNERGY, are really crucial for us, because the challenge to reach this carbon neutrality is way too large to tackle alone as a research institute or as a company or as a country, as whatever you want. So this collaboration initiatives are crucial, and that's why we're happy to be part of this